Hi. In the previous video, I talked about determination of the spherical equivalent and total refraction in addition to determination of risk factors on corneal tomography. In this video, I'm going to continue with the 5-step practical approach and talk about calculations and astigmatic disparity. Starting with calculation of thickness. As a rule of thumb, correcting -1 of total refraction ablates 13 microns from the central part of the cornea if the optical zone is 6 millimeters, and ablates 15 microns if the optical zone is 6.5 millimeters, and ablates 17 microns if the optical zone is 7 millimeters. On the other hand, any hyperopic correction will ablate 0 microns in the central part of the cornea because the hyperopic laser profile is at corneal periphery. Now, regarding the PRK rules and the LASIK rules, usually I look at the pre-op thickness and I do the calculations in order to find out the post-op thickness. Based on that, maybe I can go for PRK, LASIK, or none of them. So the starting point for me for PRK is 470, which means that the cornea should have at least 470 microns before I go for PRK. And then I do the calculations. If the post-op thickness, including the epithelium, is above 400 microns, then I can go for PRK. Regarding the LASIK, the starting point for me is 500 microns. So if the cornea has a thickness more than 500 microns preoperatively, I do the calculations for the PTA, and if the PTA is less than 40%, then I can go for LASIK. In other words, if the pre-op thickness is below 500 microns, I don't do LASIK. I may go for PRK. And if the pre-op thickness is below 470, I go neither for PRK nor for LASIK. I'll show you some examples. This is a case of compound myopic astigmatism. So the patient has -4, -2 at 180, and the total refraction is -6 because it is the algebraic sum of the sphere and the cylinder, and the central ablation depth for an optical zone of 6.5 millimeters will be 90 microns. This is a case of a compound hyperopic astigmatism. There is +4 sphere, +3 cylinder at 90. So the total refraction is +7. However, the central ablation depth is 0 because it is hyperopia and the laser profile is peripheral at corneal periphery, regardless of the optical zone. This is an example of mixed astigmatism, +2, -3 at 180. So the total refraction is -1, and the central ablation depth for 6.5 millimeter optical zone is 15 microns. Now let's do the calculations for the PRK. If the total refraction is -4 and the pre-op thickness is 480, the calculation of the central ablation depth is 60 microns for an optical zone of 6.5 millimeters, and the post-op thickness, including the epithelium, will be 480, which is the pre-op thickness, -60, which is the central ablation depth, equals 420, which is the post-op thickness. So in this case, I can go for PRK because the pre-op is above 470 and the post-op is above 400 microns, including the epithelium. This is another example. The total refraction is -7 and the pre-op is 490. The optical zone is 6.5, therefore the central ablation depth is 105. So the post-op thickness will be less than 400 microns, as you see, so I cannot go for PRK. This is another example, -5 total refraction, pre-op is 470. The central ablation depth for 7 millimeter optical zone is 85, Therefore, the post-op thickness will be less than 400 microns, so I cannot go for PRK. Now let's go for the calculations of LASIK. Now the PTA is the percent tissue altered, which is the sum of flap thickness and ablation depth, central ablation depth of course, multiplied by 100 and divided by the central corneal thickness. The resultant number should be less than 40%. It should be less than 40%. This is an example. Total refraction is -2. The pre-op is 480. The central ablation depth for 6.5 millimeter optical zone is 30 microns. If I'm going to create a flap of 130 microns thickness, then the PTA will be 33.33%. But although it is less than 40%, I cannot go for LASIK because the pre-op is less than 500 microns. In this example, the total refraction is -7 and the pre-op is 560. The central ablation depth for an optical zone of 6.5 millimeter is 105. And if I'm going to create a flap of 130 microns, the PTA will be 42%. So I cannot go for LASIK, although the pre-op thickness is very good, because the PTA is more than 40%. Now, if I reduce the flap thickness into 100 microns, then the PTA will be less than 40%, so I can go for LASIK in this example. This is another example of -4. The pre-op is 520. The central ablation depth for 7 millimeter optical zone is 68. If I'm going to create 130 micron flap, then the PTA will be less than 40%, so I can go for LASIK. Now let's move to K-reading calculations. In K-reading calculations, we depend on the spherical equivalent rather than the total refraction. So we use the spherical equivalent. We have to know that each -1 of spherical equivalent correction will reduce the mean K by 0.8 diopters. And each +1 spherical equivalent correction will increase the Km by 1.25 diopters. The final Km should be within the range between 34 and 49 diopters in order to avoid induction of any spherical aberration. Now let's have these examples. In this example, the spherical equivalent is -4. The pre-op Km is 45. The change that will be induced by correcting -4 spherical equivalent is -4 multiplied by 0.8 because it is myopic correction equals -3.2. This is the change in Km. I'm going to add this as an algebraic sum to the pre-op Km in order to calculate the post-op Km. So as you see, 45 plus -3.2, which is the change, equals 41.8, which is the post-op Km. Since the post-op Km is within the accepted range, then I can go for laser vision correction in terms of K-reading calculations. This is another example. The spherical equivalent is -8. The pre-op Km is 40. The change that will be induced by correcting -8 spherical equivalent is -6.4, as you see, and therefore the post-op Km is below the accepted range, so I don't go for laser vision correction. In this example, there is hypermetropia. The spherical equivalent is +3. The pre-op Km is 42. The change that will be induced by correcting spherical equivalent of +3 is +3.75, and therefore the post-op Km will be 45.75 because I'm going to add the change to the pre-op Km as an algebraic sum. And because the post-op Km is within the accepted range, I can go for laser vision correction in terms of K-reading calculations. In this example, the patient has +4 spherical equivalent the pre-op Km is 46. The change that will be induced by the +4 correction is +5. This will be added to the pre-op Km, and the resultant post-op Km is 51. So in this case, I cannot go for laser vision correction because it is above the accepted range. We come to the astigmatic disparity. To study astigmatic disparity, we have to note down the topographical astigmatism and the manifest astigmatism in terms of amount of cylinder and axis of astigmatism. If there is a difference more than 10 degrees in terms of axis or more than 1 diopter in terms of the magnitude, then we should consider this as significant. Now, regarding the topographical astigmatism, in case we don't have an access to the total corneal refractive power, which gives the real and true corneal astigmatism, then we have to depend very roughly on the amount of astigmatism on the anterior and posterior corneal surfaces, as in this example. We deduct the amount of astigmatism of the posterior surface from that of the anterior surface. In this case, we have 1.9 diopters of corneal astigmatism. It should be a flat axis, but here, as you see, it is displayed in steep axis, so we have to calculate the flat axis, which is almost 170. And in case of any astigmatic disparity, we have to exclude the reasons behind this, such as contact lens wear, misalignment, large angle kappa, tear film disturbance, significant high posterior surface astigmatism, corneal opacities and pathologies, previous corneal surgeries, early cataract, bad exposure to the camera, and pregnancy. As you see, they are the same causes and reasons of false positives and false negatives on corneal topography. Now, why we have to study the astigmatic disparity? In order to avoid any correction or overcorrection of topographical astigmatism or induction of against the rule astigmatism on the cornea, or induction of high order aberrations because of astigmatic disparity. I'll stop here, and in the next video I'm going to discuss how to study both eyes and why to study both eyes. Thank you for listening.